Earth-Moon-Earth, or EME, also known as moon bounce, is an exciting form of amateur radio communication. It involves bouncing radio signals off the surface of the moon to make contact with other stations around the world. This challenging endeavour requires specialised equipment and a good understanding of radio wave propagation. One of the most crucial elements for successful EME communication is antenna gain. Antenna gain represents the antenna's ability to focus radio waves in a specific direction, effectively increasing the power of your signal. In EME, where signals travel vast distances, every decibel of gain counts. A higher gain antenna allows you to reach more distant stations and achieve more reliable communication. While several antenna designs can be used for EME, this essay will focus on two popular options for the 23cm band, the dipole and the Yagi-Uda array, both mounted on a 3-meter parabolic dish. A dipole antenna is a simple yet effective antenna consisting of two quarter-wavelength conductors placed end to end, forming a straight line. When mounted at the focal point of a parabolic dish, the dipole acts as a feed, illuminating the dish and directing the radio waves outward. A 3-meter dish with a dipole feed offers a decent starting point for EME on the 23cm band. For the 23cm band, approximately 1296 MHz, each quarter wavelength element of the dipole will be around 5.8 centimeters long, resulting in a total dipole length of roughly 11.6 centimeters. Constructing a dipole is relatively straightforward. Cut 2 equal lengths of wire to the calculated length and connect them to the center conductor and shield of a coaxial cable coming from your radio. Ensure the dipole is securely mounted at the dish's focal point for optimal performance. While a dipole on a parabolic dish can be a viable option for EME, a Yagi-Uda array offers significantly higher gain, translating to better signal strength and longer distance communication. A Yagi-Uda antenna consists of multiple parallel elements typically mounted along a metal boom. It includes a driven element, the dipole, a reflector, and one or more directors. The reflector, slightly longer than the dipole, is placed behind it. The directors, shorter than the dipole, are placed in front. This arrangement focuses the radio waves in a narrower beam, increasing the antenna's gain. A Yagi-Uda array with a 2-meter boom can provide substantial gain on the 23cm band. The exact dimensions of the elements and their spacing will vary depending on the specific design. Still, numerous online resources and software programs can help you calculate these values. Construction involves cutting the elements to the correct lengths and securing them to the boom at the calculated distances. Precision is critical in Yagi-Uda construction, as even small errors in element length or spacing can significantly impact performance. Construction considerations: dipole versus Yagi. Building a dipole for a 3-meter dish is relatively simple, requiring basic tools and materials. You can construct it from readily available wire and coaxial cable. On the other hand, a Yagi-Uda array, while offering higher gain, is more complex to build. It demands greater precision in cutting and spacing the elements. The longer boom also necessitates a more robust mounting solution to withstand wind load. However, the added complexity and construction effort of the Yagi-Uda are well worth the investment for serious EME enthusiasts. The gain difference between a dipole and a well-designed Yagi-Uda on a 3-meter dish can be significant. A dipole might offer around 25 dB of gain, while a 2-meter boom Yagi-Uda could provide 30 dB or more. This difference in gain translates to a considerable improvement in signal strength, enabling you to work weaker stations and achieve more consistent communication on EME. Conclusion: taking the next step. For beginners venturing into the world of EME, a dipole on a 3-meter dish offers an accessible entry point. However, as your skills and experience grow, upgrading to a Yagi-Uda array provides a significant advantage. The higher gain of the Yagi-Uda unlocks new possibilities in EME communication, enabling you to reach further into space and connect with stations worldwide. While more challenging to construct, the rewards in terms of performance make the Yagi Uda the antenna of choice for serious EME enthusiasts.